All right, on to a few like word problems, I guess, applications. So a coach's favorite sport is hockey, so I picked that sport. Coach is choosing 5 players from a group of 11 players on the team. How many ways can she select if positions don't matter and they helpfully told us to use a combination? By the way, the combinations have just shown up, and let's talk a little bit about what a combination looks like. First of all, our book will use this combinations and R. Same idea as permutations, but they also use this notation that I've never seen before. And the reason they're using it is because it's part of what we will need in the next chapter. That's my guess anyways. At any rate, our formula for combinations. Now, when you do combinations, when the order doesn't matter, you actually have less different items. Okay, you're figuring out less different possibilities. That's the word I was looking for. And here's why. This formula looks a lot like permutations because it has n factorial in the top and it has n minus r factorial in the denominator, but it also includes r factorial in the denominator. That means we're dividing by more, which means there's going to be less possibilities with combinations than with permutations. The book actually does a pretty good job of giving you an example on why that has to be that way. At any rate, looking at 11 over 5, actually I'm just going to plug this in the calculator. Again, math, probability, and this time I'm going to choose 3 for combinations. So I'm going to put in an 11 and a 5. And the only reason I'm doing it that way is because the numbers are fairly big. 11 is a fairly large number. So I just make the choice on whether or not, canceling and reducing or putting in and reducing the factorials is going to be faster than using the calculator. Okay, so that's combinations. That is when order doesn't matter. Now, the thing that's goofy about this problem is, of course, a decent coach isn't going to just send anybody out into any position. So we're going to take a look at the same problem when positions do matter. And what they're telling us is that order does matter, which tells us to use, let's go ahead and put the number in, tells us to use permutations. So we're going to use P with 11, 5, and when I plug that into the calculator, I get a giant number, 270,725. 25. Okay, so permutations versus combinations. How many different hands of 4 cards can be selected from a standard 52-card deck? So the question is, does order matter or not? No, order doesn't matter. And a better way to actually look at this, if you remember from Algebra 2, is are we doing the same thing with all the picked items? That's a better way of describing how you choose between permutations and combinations. Are the same things happening with all the picked things? Yeah, they're all going into, each of the 4 cards is going into a hand. Okay, so order doesn't matter. So we're going to use combination. And when I plug that into the calculator, all right, I just got my 2 answers mixed up. Sorry, this one, I'm reading this off my sheet, and so I just got them backwards. 270,725, and a P of 11 and 5 is 55,440. Okay, last couple problems are actually pretty straightforward. I just included them because they model the quiz. 5 factorial And I find this pretty easy to calculate. There's 20 and there's 6. That's actually faster than picking up my calculator. This one I like, and it's, again, it's worth writing out the factorial because it will simplify. And we actually addressed this problem more abstractly with the a and the 1 in a previous problem. All right, C, it's just telling you that we've got this new format that specifically says we're going to calculate a combination with n equals 10 and r equals 7. And those numbers are pretty close together. Actually, I'm just going to plug this. Let's take a look at this. So this is going to be 10 factorial over 10 minus 7 factorial over 7 factorial. And I'm going to go ahead and spell that out times. I always feel kind of silly writing the times 1. Okay, 10 minus 7 is going to be 3 factorial, which is 3 times 2 times 1. And then we're going to multiply that by 7 factorial, 7 times 6 times 5. All right, so that all cancels. We're left with 10 times 9 times 8, which looks like it's 720 divided by 6, which gives 120. All right, we're going to also do D the same way. All right, this is going to be 10 factorial over 10 minus 10 factorial over 10 factorial. Okay, now what you need to know is, let's take a look at 10 minus 10 factorial. That's going to be 0 factorial. This number is defined as 1. If you're curious as to why that is, then Google it. But what I get out of this is 10 factorial over 1 times 10 factorial. Well, the numerator and the denominator are equal, so that just goes to 1. So whenever you have the same number in a combination in both n and r, it will always reduce to 1. All right, that's all I got for you. See you in class.